Now we want to look at how we can find the solution to a system of linear equations graphically. That solution is going to be the point where the graphs of our two equations intersect. Meaning we need to graph the two given equations in example 1 and find that point of intersection. First we have y is equal to negative 4x plus 8. We can start by graphing our y-intercept, which is 8. And then we can use our slope to find a second point. In this case, our slope is negative 4, which is the same thing as negative 4 over 1. Meaning to get to our next point, we'll move down 1, 2, 3, 4, and over 1 to find that second point. We could repeat that pattern over and over again to come up with more points, but to draw a straight line, all we need are 2 points. And what this line is showing us is the infinite number of xy coordinate pairs that are a solution to the first equation. When we graph the second equation, we'll come up with the infinite number of solutions to that second equation, and then we'll look for that point of intersection since that's the point that works as a solution for both equations. For our second equation, y equals negative x plus 5, our slope is negative 1, since we have that negative in front of x, which is the same thing as negative 1 over 1. We can start at our y-intercept of 5, and then use the slope to move down 1 and to the right 1. Again, this second line represents all of the xy coordinate pairs that are solutions to that second equation. And what we're interested in is that point of intersection, that xy pair that is a solution to both equations. In this case then, our solution would be the point 1, 4. And we could check that by plugging those x and y values into each equation and see that they would make both equations true. We'll repeat that process in example 2. Since we have our equations written in slope-intercept form again, we can start by plotting the y-intercept and then using the slope to move up 1 and over 2 to find a second point. And then with our second equation, y equals 3 halves x minus 8, we'll plot that y-intercept at negative 8 and then move up 1, 2, 3, and to the right 2 to find a second point. And then we have our point of intersection, which is the xy pair that's a solution to both equations, occurring at x equals 2, y equals negative 5. So our solution in this case would be that coordinate pair 2, negative 5. It's worth noting that while in these two cases we found a single solution, there are other possibilities. For instance, if we had two parallel lines, by definition, those parallel lines never cross or intersect with each other. So if we had two parallel lines, there would be no solution. We could also have a case where we have coinciding lines, meaning that the two equations, even though they look different, end up overlapping with one another. In that case, there would be infinite solutions to that system. But for our purposes, we're going to focus on cases where a single solution exists.